All right, there we go. Okay, so noticing the differences between quadratic, okay, versus exponential models. As I was saying, there are small and subtle differences between quadratic and exponential models, which is usually why when trying to determine which model fits best, they'll actually run both of them. But if you can try to guess at one over the other, then you can try to essentially, instead of doing double the work, you can only do one model. So we want to make sure we notice this subtle difference. So our exponential regression here is the function in the red, and our quadratic regression here is the function or the graph in the blue here. Now, if you want to pay attention, which is very important, you want to pay attention to your x-axis and pay attention to how quickly things are moving here. So we're looking at years here, it looks like. 1819 all the way to 2015, it looks like. Okay, so 1819 all the way to 2015. So all of these are very small intervals here, or very tight intervals, I should say. Okay, and then we have our y-axis here that goes from 0 to 160. Now, I'm not sure what this graph represents, but we want to make sure we notice like the increase here for the y's as the x's increase. So if we take a look here, you'll notice, what's one thing that you notice about exponential versus quadratic? What's a good notice about these guys? Okay. Okay, good, Lumeria. Exponential is growing faster. Right over here, we can see that, right? And quadratic almost looks like a line here, but there's a reason for that. This is really zoomed in. Like if we're looking at years here, right? This is really zoomed in to like just the area where that curve happens. So if you'll notice, yeah, exponential most definitely increases faster, right? It's growing much faster than a quadratic, and it's like almost like a very sharp turn. So it's definitely growing faster. Right? Whereas a quadratic is more comparatively, it's more of a gradual growth. Okay, it's a slower steep. Okay. So you want to pay attention to the curves of your graphs, because the curves of your graphs will help you determine if we're looking at possible exponential or a possible quadratic regression. Okay. So our goal is now to take a look at all these different functions here and determine if they are quadratic or exponential models, and then justify our responses. Okay. So I'll leave that up there for now, just in case you need to get that down for exponential and quadratic. Okay, so it says determine the following models. Okay, so taking a look at the first one here, we're going to do this through polls, and I'm going to take your guesses here. Okay, so I will launch the poll. This is for number 1, and you tell me what you guys think. Do you think this is an exponential function, or do you think this is a quadratic function? Okay. Still waiting on 2 more people to vote. Oh, there we go. 10. So I got 10 out of 11 of us. I'll give us 10 more seconds for the 11th person. All right, so let's take a look here. Okay, so 9 out of 10 of you said that it was exponential, and 1 person said that it was quadratic. Okay, so you guys want to take a look at that? Okay, majority of you guys thought that it was an exponential. Okay, and the majority of you guys would be correct. Okay. It is exponential. This one looks more exponential. We have a bit of a more gradual, I'm not gradual, a sharp decrease here. This looks a lot like an exponential decay, right? And then if you'll notice here, it kind of evens out as if it's like approaching an asymptote at the x-axis, right? So it's almost like it's approaching that asymptote there. So yeah, this would be exponential because it is a fast decrease right there, and it seems to be approaching, I can't type, or write, I'm sorry, approaching an asymptote. Okay, so exponential because it is a fast decrease and it seems to be approaching an asymptote. Okay. Okay, so I'm going to leave that writing there, but I'm going to move down to number 2 here. And on this one, I'll give you guys a moment to think about it. Quadratic or exponential. I'm going to put the poll back up. Okay, putting the poll back up. Is this an example of exponential or quadratic function? Okay, I have 2 responses. I apologize, I have 4 responses. 6. Oh wow, neck and neck. Remember, this writing is from the previous one. I'm just leaving it up so that anyone that needs it can still write it. Wow. Very interesting. Okay. Okay, gonna give 10 more seconds for our 11th person here. All right. So it's pretty neck and neck, guys. I don't know if you guys did that on purpose or what, but it looks neck and neck. Half of you thought that it was exponential, the other half of you thought it was quadratic. Can someone who thought it was exponential share, please? Any of the 5 of you that thought it was exponential, can you unmute and share why you thought it was exponential?
It's starting to look like a parabola, kind of like towards the end. It looks like it's gonna curve up, so that's why I assumed it was gonna be exponential.
Wait, so parabola is exponential?
I just assumed.
Yeah, but a parabola You're right in you're I can see what you mean when you say it's curving up, so it looks like a parabola. But is a parabola what we call an exponential graph? Interesting. Okay, okay. Can anyone explain why they chose quadratic? Thank you, Oswaldo. Any of my 5 who chose quadratic? Can you unmute and justify? Come on, guys. The longer this takes, the longer we're going to end up spending on this, and the other activities are going to end up being homework.
I thought it was quadratic because it looked like it wasn't. It looked like it never touched the x-axis.
Does it look like it's going toward the x-axis at the bottom here?
Yeah,
It does a little bit, right? But then what happens?
it curves up.
Right. It curves back up. Okay. So whenever you, thank you, Anthony. Appreciate that. That was Anthony, right? That was
Yes.
not. Okay. Okay. Thank you for that. So yeah, whenever it curves back up, that's why I was like shocked with Oswaldo, what Oswaldo was telling me, right? Exponential functions, they don't curve back up. They just get closer and closer and closer to your asymptote. Whereas a parabola does hit a minimum point, right? And then it curves back up, which means that it's going to be a quadratic function. So over here, this would be a quadratic. And yeah, that does have a lot to do with the points and how they're a little bit more scattered. But again, this is a regression, right? So it's not a perfect model. So, but we can see from the points here, right over here, it does end up curving back up right around here. So like these points here are a little bit more scattered. We have low, 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 and then we go back up here. So this is going to be a quadratic model, okay? Because it looks like it's turning upward, literally, right at on the right side. Okay, so it looks like it's turning upward on that right side there. All right, so again, I'm going to leave that writing there, but I'm going to scoot on over to number 3 here. Okay, scooting on over to number 3 here. Once again, the question of exponential or quadratic. Okay, exponential or quadratic. So I'll give you guys 30 seconds to finish writing and taking a look at this, at the third graph, and then I'm going to launch that poll. Okay, so same question. Is this an exponential or a quadratic? Exponential or a quadratic? I'm going to go ahead and erase this. while you guys are doing that. Exponential or quadratic? Okay, I have 9 out of 12 of you. I am waiting for the rest of the responses. This is only 75%. Okay. All right. So let's take a look. We got 11 out of 12 of us voting, and 10 of you said exponential. 1 of you said quadratic. Okay. So taking a look at the turn here, okay, we should see that this is a bit of a more sharp turn. Okay, it's a bit of a more sharp turn here. It's coming down, it's coming down, it's coming down, and then it automatically turns and starts getting kind of flatter. If this was more of a parabola and we were decreasing, it would look more along the lines of this. So it'd be more of a gradual decrease as opposed to this sharp decrease and then a flat out. Okay, so if you'll notice an exponential, it kind of like starts really high, and then as it gets low, it has that like moment where it turns and then starts flattening out. Whereas a parabola, it will get smaller and smaller and smaller, but it'll keep getting smaller and then flat out for a small second and then start turning back up. And that small bit is like usually your vertex, but it's a more gradual decrease as opposed to a sharp turn and then flatness. This also looks like it's probably approaching an asymptote of the x-axis. And yes, they're scattered, but it's kind of how they're looking there. So in this situation, yeah, this is actually an exponential model. So I'm going to do this real quick because I'm going to need that space later. And then, so this would be exponential here. Okay, we had a very fast decrease, sharp turn, and a flattening toward an asymptote. Okay. All right. So that would be that one. Let's take a look at number 4. Number 4. Launching the poll here. Okay. When you're ready, let me know. Number 4. Exponential or quadratic? Number 4, guys? Look at the whole thing. Interesting. Okay. All right. Let's see. So we had 7 of you say exponential, 4 of you say quadratic. Even though, even though you have this function written right here for you. What kind of function is that? Is that an exponential function or a quadratic function? Look at the function itself. Is that exponential or quadratic? This guy right here. Oh, can't, apparently. Hold on. That guy. That's a quadratic function. Yes, it is. Okay. Now you're probably thinking, well, Miss K, what if they were just trying to trick us? They could have been. But look how nicely that fits the points. Okay, look how nicely that fits the points. Also, if we're taking a look at it from graphing, right, from the graph standpoint, see how it's gradually decreasing, where it's a slow, nice, and steady decrease toward the end, and then it flattens out right here. If this was more of an exponential, we would have had something that was like, if we were to use these flatter points here, we would have had something that was more a sharper turn. Okay, a much more sharper turn to get to here. Or if we're using this point here, we would have had something along the lines of this, where we have a more of a flatness, 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 and then a sharp turn up. Okay, that would have indicated more of an exponential graph versus this one where it's a very gradual, nice and steady increasing. There's no sharp turn. It's a nice wider turn that it's going up toward our points here. Okay. Also, if we take a look at it, we have our function here, right? Our function gives us an r squared. It tells us that our r squared is 0.9993, right? So if I want r, my correlation coefficient, I can just square root this guy. And when I square root that guy, I get my r as a 0.9996. Okay, and what do we know about our correlation coefficient here? The closer it is to 1, then the function is what? The closer r is to 1, then what does that tell me about this function here? Come on, we're trying to remember. The closer my correlation is to 1, then my function is what? Hope you guys are shuffling through your notes right now. Yeah, stronger correlation. What does that mean for the function? What does that mean for this equation, for these points? Yes, it does mean the strength of the relationship between the points, absolutely, right? But then we also have our r squared here, right? So our points have a very strong relationship. They have a strong correlation. That means that, right, they don't cause each other, but they are strongly related to each other, okay? And then we have our r squared, which tells us how well It tells us how well our function fits our given data, right? It tells us how well our function fits our given data. This is like our regression. So R squared is our regression. So our regression is also very close to a 1. And the closer the regression is to 1, the better our function fits our data. So since R squared is also very close to 1, that means our function fits our data very well. Okay, our function fits our data very well. So we can say here that this is actually a quadratic model. Okay, this will be quadratic. Okay, since the model has an R squared that is very close to 1, meaning it fits the data very well. Okay, moving down to I'll keep the quadratic one up. So moving down to number 5. And moving down to number 5 here. All right. Launching my poll. Actually, so far, before we do the poll, in the participants window, go ahead and tell me how you feel about how you've been doing with these. A thumbs up if you've been getting majority of them correct and you feel like you're understanding this. Thumbs down if you're getting the majority of them incorrect and you feel like you're iffy on this. Okay. If you're neither thumbs up or thumbs down, then give me a check mark. If you're like in the middle somewhere, give me a check mark. Okay. Aaron, you there? William, you there? All right. Okay, thank you so much. So if you have any questions, I would like you guys to ask them. That would help me know what to focus more on or what explanation to focus a little bit more on. Because I won't know that until you guys tell me what you need. So help me out here. But let's take a look at number 5 here. Okay. Again, take a look at the different ways that we've been identifying. So look at the curve, right? Look at the numbers. Look at this curve here. Is it like, is it really high and then a sharp decrease and then a flattening out? Or is it a gradual decrease here and getting toward the bottom? Is it like a wider, like a parabola, or is it more like an exponential where it's a sharp down and then flattening out? So those are some characteristics you want to look at when you're looking at the graph, right? So looking at that, I'm going to relaunch our poll. Okay. And once again, same question. Is this an example of an exponential function or a quadratic function? Okay, I have 8 out of 12, 9 out of 12, 10 out of 12. Last two. Come on, guys, you can do it. Okay, so far quadratic for the win. We got 4 exponential, 7 quadratic. So the majority has chosen quadratic. And the majority would be correct. Okay, so this is a quadratic function. And the main reason for that is we have more of a gradual decreasing of our data. And you can see that from this curve here, right? It's this curvy area right here where it changes, okay, from this flat. And, you know, we don't know what's going to happen here. We don't know what's going to happen as we go on. But this curve, right, is more indicative of a quadratic curve than an exponential curve, because the exponential curve would have been something where it actually came more and went more like that. It's more of a sharper turn when it goes from this small to an increase. Whereas a quadratic curve, once again, is a lot more, it's a lot wider of an increase. Okay, so this is a quadratic model or quadratic because it is gradually increasing. Okay. All right. So let's take a look here. If this one's not obvious, then we got a problem. Okay. If this one's not obvious, then we seriously have a problem. Okay, I'm going to relaunch the poll here. Look at the movement of the data. Okay, look at how the points are going, what shape the points are in. Okay, so I got my 9 out of 12. Waiting on the last 3 here for my votes. I feel like someone is like purposely being devil's advocate. But hey, that just might be my feeling. Okay, still waiting, still waiting, still waiting. Quadratic is in the lead, 9-1. All right, quadratic is in the lead, 10-1. Let's share that. Okay, you guys are absolutely correct. If this doesn't look like a parabola, then I don't know what else does. Literally like curve and then bam. So this would definitely be a quadratic function. because it literally looks like a parabola. So I can understand why someone might think that that's exponential because of like that sharp decrease. But I mean, the whole shape of it trumps that sharp decrease, right? Exponential functions, they don't get low and then go back up high. They get low and stay low. So if it's going back up, then that's for sure going to be a quadratic function. There's no ifs, ands, or buts about it. Okay, let's see. Moving on down, number 7. Okay, so we have 7 through 10 here. 7, 8, 9, and 10. Okay, that I'm going to actually allow you guys to do on your own. And then when you get down to here, number 11 and 12, it says use the tables to determine if the following models are quadratic or exponential models. Okay, you don't need to get fancy here. You can literally look at the values. They're also not necessarily all moving in the same increments. So you could try to do like the ratio or the second difference, but honestly, if you just look at the values and how they're increasing or decreasing, it might be able to tell you if you have a sharp increase or decrease. That would make it a exponential. If you have a gradual increase or a gradual decrease, then that would make it a quadratic, right? So 7 through 12, I'm going to allow you guys to work on this on your own. I believe we're going to have to do 2.6C on Thursday, which is okay. I'm fine with that. Whatever. This will take you time anyway, so I want to give you class time to do that. So 2.6B here, 7 through 12, that's on you guys. Okay, to the end of the period, and we will go over it. Not kidding. I will be asking you for your results at the beginning of next class period. But I want you guys to stay on the Zoom right now in case you have questions. Okay, so you have 20 minutes to do all of 6 problems. You should be fine. There's no calculations here. Okay. All right, go ahead and get started. If you have questions, please, 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 please ask them